Okay. Let's see. And okay. Yep. Just a second. Okay. Okay. So let's get started. Okay. Hello, everyone. Hello, Graph community. So another community meeting. So we don't have new joining. So okay, I will get started. So today I will update you some new news of the NebulaGraph projects, and then I will give a quick sharing on a small topic that what I had summarized and experienced on the graph database, the graph dataset generation. So we don't have new ones to be introduced. And as usual, so anyone want to join the community meeting, just be sure to check out, subscribe, register in our Zoom meeting. So you can check out this link. This is the Etherpad that everyone can put your proposal, your questions there, and be sure to join our Slack channel. We have in NebulaGraph Slack site, there is a community meeting channel, and you can get everything notified there. So we have this meeting bi-weekly, and we will regularly have the project's updates and at least one of the ad hoc topics. And if anyone want to have an open floors for this discussion on any problems, just come and join. And if you want to involve someone in specific domains, just let us know before the meeting. And yep. So today, the project updates, there are not too much in this cycle because we just have one release of 3.1.0 weeks before, and our next release will be around July. So from the NebulaGraph core database site, we only have like less than 10 PRs merged. So I will go through the major ones. So this one is optimization in the subgraph that previously when we query subgraph, even the last node, we will have this all its neighbors, which is actually next step to this node. But that's actually not necessary if you don't want to yield those. And so we have this optimization in the plans now. So please expect performance improvements. And another one is related. So this is an issue number. So you have a bunch of different match performance optimizations. So one of them just merged days before is related to when you are doing a match with the starting node with VID. In that case, you don't need to use the index, right? In that case, all the other filters in the where clause is actually not needed because you already pointed to a starting point specifically. So this optimization was applied with this mindset, and there are actually some ongoing PRs on this topic. So they are quite interesting. So if you're interested, just check out this issue number. The last one that worthy to be mentioned is we fixed one of the rare case related to rough snapshot of the listener. So it's a quite interesting PR. So if you can check out the numbers. The other big news is that I want to share is Nebula-Go. So last time of meeting, Tiago joined our meeting, who is so very great man. So, and in last 2 weeks, he contributed on a bunch of different PRs on Nebula-Go. So two of them were already merged. This one is the first one is in 200 PR number. He removed some some code that's not actually needed, and that part of code is blocking us from leveraging newer version of Go, and that's thousands of lines of removal, which is quite satisfying. Another big thing is it's already merged, and this all of those PRs are contributed by Tiago. That previously we put every test in one Go. There is no distinguish between the integration test and the unit test. So actually, most of the contributor only would like to run the unit test to justify their modification. Don't break anything. But by default, previously it's quite heavy to bootstrap a whole cluster in container with Docker Compose. And now Tiago brought us changes that you can purely run the unit test without the heavy integration tests. So there are a bunch of more. One of them that I would like to quickly review and merge is Tiago helped assemble the very first version of the code of conduct for the NebulaGraph Go repository that I'm thinking of bringing it to all the projects as well. He was also working on the IPv6 support on the Nebula-Go client, and he brought multiple Go versions in test. So this is awesome and really great work for the Nebula-Go. Another one is this is a huge change, and it is a huge pain point for all of our clients. For now, we really lack of proper wrappers and elegant design in how the server address could be configured. So the term of the leveraging a proper designed connection string will be perfect. So I'm looking forward for this PR to be merged, and I would like to promote this design to the all the other clients as well. It's quite cool. Thank you, Tiago, so much. So the next one is on Nebula-node. It's a Node.js client. It's not in the vsoft org, it's under Nebula contribute org. So this PR was just pushed last night by JJSI MPS. So he or she helped solving a bug in the ping function, which is quite cool. I think maybe it's the first contribution that he or she contributed to NebulaGraph community. So thank you so much. So that's the project heartbeat part. And then we will go to the ad hoc topic. So I will give this topic as usual. I will invite more guys to share topics in the future. So this is about, actually, I have the experience to generate some data set, some dummy data set on my own to, test something or create something based on that. So they are all graph structured data sets. So I'm thinking maybe I can share some of the methodology and experiences that I like some problems I faced and mitigated. So here's the topic. I hope it helps you. So I want to start with the problems that I encountered. Some of them was a little bit challenging, and not that straightforward to be solved. The very first one is a very trivial one, but that we want to generate a data set. Everything is random, it is dummy, but still you want it somehow make sense. So we're generating data mapping to our property graph module. So the properties like the names, company names, the role, and someone work at some other corporations in specific roles, their age, their addresses, their names, their gender. So those are things will be too lame or too boring if you just give random words as the specific field, and that will be working, but it's not elegant. So that's a problem. And luckily there are always a faker library in almost every languages. So I was using one of them. The next one is the relation or edges relationship generation. So it's easy to be understand that you can generate nodes or vertex with like faker. But how do you generate randomly relationships between different nodes? So one of the way that I was doing that was making the vertex ID in a number of cases, and it's making it continuous. So in that way, you will know the range of valid nodes or vertexes. So then the randomly generated relationship will be referred to randomly generate two numbers in specific ranges. So that will be easy, and that's the way I do it. I think everyone who encounter this issue will come with this solution. It's quite straightforward, but it works well. So a next problem or challenges is sometimes you want data, partial of data to be true, connected to the real world, and I encountered that issue as well. I want to generate a dummy data set that reflecting to a knowledge graph that's defining the people in the society living in different addresses, that they were reflect the virus, the coronavirus, the COVID-19, how it's spread in the society knowledge graph, that every node is a person. So I have some experience that I want to share later. So the most challenge now that I managed to figure out how to fix is some of the for some purposes that we want to leverage some generated random data set. You want to have some sort of graph-wise structure. For example, you want your generated data to have a community structure, and even some community structure that you want to configurable to be, like you want 1 billion of nodes that you want to have 300 communities that they are clustered in some way. So that's not be able to be done randomly in a naive way. So I managed to find one of the papers that's working well on this purpose, but it's becoming tricky because most of the algorithms was doing the work to generate that, assuming every nodes and every relationship are in one single type. But how about heterogeneous graph that you have different type of nodes and different type of relationships? How could that be resolved? That I will share my approach that works. The final problem or challenge is how do you label data? Like you want to do fraud detection in your graph data. It's randomly generated, it's not real world data, but some of the nodes should be flagged as high risk, some other are not. You want to do some graph query or graph learning to find the relationship between the the ones with the flag and the one without. But how do you make this flag making sense? So it's quite tricky to me. So then I want to quickly share the solutions. So as I mentioned, I use the Python Faker module to generate the properties, as I mentioned already. And also, how do I generate a relationship? You just make the VID, make a VID in a containers number, so you can do the range randomly generation of the range to have the edges. So you can actually, this is the very first data set that I tried to generate, and it works well. That's also the data set running on the NebulaGraph playground, reflecting the relationship between the people and cooperation and some between them, how one people hold share of other corporations in different jumps of relationships. And I will introduce that later. So how do we connect fake data to real world data? And that could be done. You just grasp those from the public domain. You just make some processing works, and that solved the work. In this repository, I create a dataset generator to create randomly people, and with randomly a flag that they lived somewhere. Those specific address, like the building name or the room number, they're totally fake. They don't exist in the real world. But what this place belongs to a street, and the street belongs to a district belongs to a city belongs to a province belongs to the country. So those are all real data, and I make it I make everything connected, and it works like charm. So next one is how do you contain the maintain a data in a defined or expected controlled graph structure. So in this case, I want to create a data set for fraud detection with a specific community structure. So I couldn't find a straightforward way, so I tried to search some papers, and I found this. So this is a paper related to fast random graph module generation with the community structure, and the author even shared their workable, runnable module code in Julia in GitHub. So their module named ABCD refers to artificial benchmark for community detection. So and that's where I leverage this package to generate community data. But the next challenge will be those modules only generate one type of points or nodes and one type of relationship. But how do we apply to our heterogeneous graph. I will share more later. I make some transformation to make it consistent, make the structure not change, and apply to a heterogeneous graph. And so the final challenge that I encountered is the labels in data. Like how do you make your part of the nodes with the flag in truth, the other in false? How do you decide? You just randomly do that. In most of cases that works. I just randomly created them and make the the proper possibility, the chances how it's setting true configurable, and that can be easily done. You can check out my codes regarding those parts. So that's what I do now. But in the future, if I have the requirements, I have the time to make it even more useful and meaningful. I was thinking that maybe I could reuse some of the real world data. For example, if you want to create some knowledge graph based on randomly generated data, most of like the structure, the properties, but you want to keep some subgraph of the community or connections, more like the real world. You can leverage some other open data like the live journal or Twitter data. That's actually in the real world stands for the social network, but maybe in your data set is for another purpose, but it doesn't matter. Natural extracted structure can still benefits, and even and this this theory can apply to the flag domain, like how do those people how many of them are considered as fraud, some other are not. You can leverage most of your data are randomly generated, but the flagged one, the labeled one, reuse the real world data. That I think that's a doable, feasible approach, but I didn't try it. I will share my further experience when I got bandwidth to do with that approach. So another, and you can do it either together or a totally different alternative is you can do it with your domain knowledge study to be consistent with your generated community structure or other graph structure. For example, in the fraud detection, you generate with like a bunch of like 100 communities, and you know which node belongs to which community. So when you are flagging them, even you are doing it either randomly or connecting to the real world, you can still leverage like if this community, one of this community are flagged as a high risk, and you can make the other nodes in the same community in a higher probability and a higher chance to be labeled also as a higher risk. So that will make the whole data even more meaningful, hopefully. So I didn't try that, but that's in my mind. Maybe I will do it in the future. So before I finish this topic, I would like to give a more detailed introduction of the 3 projects that I created to generate random graph data, and that and all those experiences comes from those ones. So the first one is the very basic one that I basically just apply the approach of generate meaningful properties and randomly created the edges. So the code can be found here. So I just generate the nodes like in a specific range, also generate corporation specific range. So their names, address, and those rows, like the property in the edges, they are all generated from Faker. So they're meaningful but totally random. And those relationships, you just randomly choose 2 numbers and make them sitting in the range of the different count. Like you have 100 person, so you cannot make the starting point of this lag larger than 100, right? So you can do that in a randomly fashion, and it works well for me. So the next one is how I connect the real world data to the generated data. So this is the module that I randomly generate a person and address, and the street belong to the district, they belong to town, belong to city belongs to the province. Those data are real world data, and I grasp it from the public domain and put it in this project. And yeah, the belong to lag here, the belong to here is also from real world, but the people live with person and person visit with address, those are randomly generated lags. So it's with the same method as the last one. So be sure to check out this code if you are interested. And the last one is how I apply the community structure data to the heterogeneous graph. So this is the module in the left part. We have the people, they will apply as the loan applicant. So they will apply for a loan application. And we have some other information like the people in this application table, they will fill the information like they worked for some corporation. When they are doing this online, they used to use specific device. So you have a unique device ID of the like phone or computer, and people, they will have their phone number, and the corporation will have phone number, and people will have their emergency contact with another person, and those person are having another phone number. So they could be, you know, connected in some way. But how do we generate such graph to do a fraud detection test? And the data should have expected community structure, like you want to have 10,000 of person, and you want to have like 200 communities. How do you do that? So as I mentioned, I checked for the ABCD, you know, the paper, and make it working. So what the paper will help us generate a community, a lot of points, about vertices with one kind of connections between those one single typed vertex, and those connections will generate like 200 communities for you. It's not directly configurable. You just configure some other angles of the parameter, but it will end up with like 200. You can tune the number to have how many, the scale of the community structure you would like to. But that's details. You can refer to the documentation of this project. But you know, you have this kind of relationship, but it's for single typed data. How do you make it community structure with the different kind of multi-hop relationships? And this is what I do. So data generation in the code part will be reflect to 4 steps. So the very first step is you just randomly generate a person, as we do in other projects. So in the second part, we are leveraging the ABCD, the paper, to help us generate person and their relationships. So, and that contribute to the structure with the specific community, the clustered structure. So how do we make those structure into heterogeneous graph? I just define a specific way of the multiple connections and make it and break down all the direct simple connections into those different kind of, you know, multi-group connection. Like you have 100 of the blue connections from person to person, and then you randomly choose, like you can define the ratio, like you want 100, you want 10% of the connection to be in the pattern of person, device, person. So it's a shared device connection. Then you will have 10, randomly select 10 of the connection in this way. Similarly, maybe you have 20 of the connections in this one to have, they are sharing phone numbers. So you can do this for all the different patterns you define. And the key point here is you have now generated a hypergeneous graph with the structure exactly same as this one. If you count those connections as the connections, and they are weighted in the same way. So if you are running a algorithm to compute how many to detect the communities, it will result in exactly same structure with the one we generate in the second step. So this is how I did it, and it worked well. So I think that's worth it. This is the most worthy to be shared part in this step. And then finally, you have the persons between the relationship between the persons, and that keep your community structure. And then finally, I just randomly generate the applicant apply for loan application relationship in the final step, and all the connections here never break the community structure generated in step 2. And you can check for the, be sure to check my code, because I actually I have wrote a quite beautifully command line interface here. So I want to share it to you. So we almost finished. Okay, the network is not perfect. So be sure to check. Oh yeah, this is the how it's running in your command line. It is quite satisfying to me to have this fancy, you know, the command line. I love it. Okay, and that's the final part of the one. So the future work, last but not least, what I could do in the future, I will do more studies on how I should make the label data making more sense. So yeah, as I mentioned, I want to leverage the partial real world data. Maybe it's on different domain, but still we can make it more meaningful. And I want to combine the domain knowledge and the graph structure and make it consistent. If I put some effort to make it more self-consistent, I may get some more meaningful results, I guess. So another part is the performance. So if you want to generate like 10 of billions of nodes, and my current implementation will be the bottleneck because it's running in Python, and it's a single, it's not, it's a single thread. So maybe in the first step, I may make it more concurrently or parallelized computing way of working. Maybe I don't use Python or use the multi-processing to make the async things, or some of the steps can be do in parallel. So another thing I will looking forward, I will watching some new papers, maybe some new algorithm will be faster. Yeah, that's the other part I would like to improve. Yeah, and that's all part of this topic. Okay, and so see you in 2 weeks. Be sure to check out our Slack channel to know how and in our GitHub wiki you will find the Zoom link just so you can register the meeting here. And we are having our managed service, our NebulaGraph as a service cloud in Asia. So you can search graph database in Azure portal, and you will see here, this is the NebulaGraph cloud, and be sure to check that out. And let's call this a day. Thank you. Bye-bye.